edges for the purpose of what? Why we need to prune the tree? What is the purpose of pruning the tree? So to enhance the efficiency of the results, classification results, and to increase the speed and performance. So we are going to prune the tree, and we are going to prune the branches of the tree which actually represents the noise or outliers. So we are having two pruning techniques, pre-pruning and post-pruning. So coming to the pre-pruning, in pre-pruning, we are going to, that means at the time of developing the, at the time of construction of the tree itself, we are going to prune it. That means at every stage we need to check the goodness of the split by using certain strategistical methods. So we have information gain ratio, information gain Gini index. We are having for assessing the goodness of the split, and based on certain threshold, we can decide whether to develop the particular branch or whether we need to stop there. So that is based on a threshold, and that threshold should not be too high and should not be too low. To generate a moderate pruning process, the threshold, fixing the threshold should be very important. And coming to the post pruning. So in post pruning, first we need to generate the decision tree. We need to generate the complete decision tree, and after that we need to prune it. We need to cut the unnecessary branches. So if at all particular subtree is removed from the tree as a part of post pruning, and that should be replaced with a label, with a class label which is frequently occurred in the particular removed subtree. So all these we have seen in the last class itself. And similarly, we are having we have entered the topic, the next classifier, that is Bayesian classifiers. So Bayesian classifiers are mainly based on Bayes theorem, and in the last class we have discussed that Bayes theorem also. Let me share the PPT once. Otherwise, let me share the whiteboard. So what is the Bayes theorem? What is the Bayes theorem? It says that posterior probability of a hypothesis given the observation is equal to posterior probability of this into P of H by P of X. And this is the, where P of H by X is the posterior probability of the hypothesis given X. P of X by H is the posterior probability of the tuple given hypothesis, where P of H is the prior probability of the H and P of X is the prior probability of the X. Now, what is the Naïve Basian theorem? This is the Bayes theorem. What is the Naïve Basian theorem? Naïve Bayes classification. It says that according to this, if a tuple X belongs to the particular class Ci, if its posterior probability given X should be greater than all other classes. So yesterday we have seen the same condition. So the posterior, if and only if the posterior probability of the particular class Ci given X should be greater than all other posterior probabilities of the classes. That means should be greater than P of Cj given X, where that J should be lies within 1 and M, and also I must not equal to J. This is the condition as in the last class we have discussed about. So here the posterior probability of the class should be greater than to the all other classes. If at all that is the case, we can say that the tuple X belongs to the class Ci. I think it is clear till now. Till now we have discussed in the, this concept in the last class. So if at all we are having two classes, if at all we are having two classes C1 and C2, X belongs to which class? How we can classify the tuple X? So we need to, for this we need to find out the posterior probability of the first class and also posterior probability of the second class given x. So whichever the value is greater, we can conclude that x belongs to that particular class. If at all its value is some 5, its value is 5.5. So it seems it's a greater value. So we can say that x belongs to the class C2. Like this, we can, in the Naïve Bayesian classifier, we can classify the tuples. Then here, our goal is to find posterior probability for each and every class. Our goal is to calculate the posterior probability for each and every class. So here, how to calculate this P of Ci by x? So from the Bayes theorem, we are having this formula and we can write here like P of Ci by given x is equal to P of x by Ci. Just replace h with Ci. In this formula, replace h with Ci. P of x by Ci, P of Ci by P of x. So this is the posterior probability, formula for the posterior probability from the Bayes theorem. Now we need to calculate this, we need to find out this for each and every class. For each and every class. That means for class C1, what is the formula? P of x by C1, P of C1 by P of x. And for class C2, what is the formula? P of x by P of x by C2, P of C2 by P of x. Right or not? So for class C1, the same formula is like this. P of x by C1, P of C1 by P of x. For class C2, P of x by C1, P of C1, C2 by P of x. Similarly, for class C3, what is the formula?
P of x by C3,
P
yes. Of C3
yes.
by P of x.
P of x. So like this, how many number of classes we are having, the formula can be expanded like this. Not expansion. For each class, we need to find out that posterior probability of the class. How many classes we are having? For those many number of classes, we need to write the formula and we need to calculate that. So what's our ultimate goal? We need to maximize this. That means which value out of 3, suppose we have 3 classes, we have written the formula for the 3 classes here, right? 1, 2 and 3. So out of these 3, which one is greater, that value should be considered. I think here if you observe, is the denominator is necessary to compare? To comparing the biggest value among the 3, is the denominator is necessary? We can remove it here or we need to place it? Why? Because our aim is to not to calculate the result of P of x by C1, P of C1. That is actually not the ultimate aim. Our ultimate aim is to calculate the to find out the class which have the maximum value. That value we don't want. We just want the class which got the maximum value. So just we are going to compare the results after substituting the formula with the values. We just want to compare the results. So for this, since P of x is common for each class, I think we can remove it, right? Did you get my point or not?
Yes, ma'am.
Why? Because our intention is not to calculate this particular value, not to calculate this value. Obviously, we need to do that, but our main intention is we need to find out the biggest value out of these 3 formulas we are having. It results in 3 different values. So our ultimate aim is to find out the biggest value among the 3. So comparatively, if at all there are n number of classes, for each class we need to calculate the posterior probability, and for each class this denominator is same, P of x, P of x, P of x. So the same, that means that results in the same value. If suppose the value of P of x is some 10. So for every formula, the value is 10 here. Since we are going to compare the ultimate results, we can remove the denominator. So our goal is shifted to the lower boundary. So now what's our goal? We need to calculate P of x by Ci, P of Ci for each and every class. That means we are assuming that the P of X is constant. So we no need to place it in the formula. So our ultimate goal is to calculate P of X by Ci, P of Ci for each and every class. So here P of X by Ci, P of Ci. So now I can say that the tuple X belongs to the class Ci if this particular value should be greater than P of X by Cj, P of Cj. Similarly, where j belongs to 1, j is in between 1 and m, and j not equal to I. That means the same formula I have by following the Bayes theorem, we have expanded that. We have expanded like this. So if I can say that X belongs to class Ci, when I can say that, if at all this particular, the whole thing should be greater than the remaining classes. This is the posterior probability of the tuple X given the class, and this is the prior probability of the class. And the product of these two, this is 1 and this is 2. The product of these two should be greater than the remaining things. The same condition. That means the formula is little changed here, little bit changed here. So our goal is here to calculate this P of X by Ci and P of Ci, right? To calculate this value, we need these two. We need these two. We need for each and every class. So just understand what I am telling. Our aim is just changed. That means our boundary of calculation is reduced. Initially, suppose we need to calculate the area here, and by removing the denominator P of X, our boundary is reduced. Here, this is the value we need to find out. We are just reducing the problem scope. So our new aim is to calculate the posterior probability of X given class Ci and prior probability of class Ci. Now, Ci in the sense we need to calculate these two for each and every class. And finally, when the X belongs to the class Ci, whenever the product of the values of these two of Ci should be greater than the remaining classes. Just listen carefully, otherwise you may get confused. We are just expanding the formula. I again explain the same things by showing in the PPT also. If at all you are having any little doubts, you can all the doubts can be rectified when we are moving for the PPT. No problem. Just listen and try to understand. So here what we are doing, we're just now our goal is shifted to this. Previously, what's our goal? We need to calculate the posterior probability of the class given X, and this should be calculated for each and every class. And we have expanded this using Bayes theorem. And after that, we are removing the denominator for each calculation. Why? Because it is constant for all the classes. Now we left with this. Now we left with this only. So our new goal is to calculate this part for each and every class. And the class which gets the maximum value for this product should be the class where the tuple X belongs to. So now the question is how to calculate P of X by Ci and P of Ci. How to calculate that? P of Ci in the sense, we already know that probability of the classes, probability of particular class. So we have calculated this many number of times. It can be obtained like this. What is this? This is mod CID by mod D. That is a value equivalent to this probability. What is this actually? What is mod D? What is mod D? Mod D. What is mod D? What is D actually? What is D?
Data set.
Data set. What is mod D?
Number of tuples in data set.
Very good. Number of tuples in the data set. Then what is mod CID? Just guess. We have did it many number of times. D is
Number
the
of tuples
yes number of tuples.
In a
in
class.
CI. Class CI.
Yes.
Number
So,
of tuples in
yes,
class.
yes, very good. So mod D is the total number of tuples in the data set, where this mod CID is the total number of tuples in the data set having the class CI, having the class CI only. So in this way, we can find out the probability of class, prior probability of the class we can calculate. And we are left with this, how to calculate this one. What is that? P of X by Ci, how to calculate that. So that is depends on the number of values for the attribute X, sorry, number of attributes we are having for the tuple. So that is the complexity of calculating the P of X by Ci is depends on number of attributes that a tuple have. If suppose this is an example, the tuple is taken from the student database. How many possible number of attributes we are having for a student database? Student roll number we want, student name, student marks, branch, section, department, etc., etc. So all those are referred as the attributes. So based on the number of attributes, the complexity of this is depends. So here, if at all the attributes are too many for a data set, in general, there is a dependency among the attributes. I already told you, right? During regarding the dependency among the attributes, in the last class we have taken an example. What's that? In explaining the dependency of the attributes, in the last class we have considered an example. What are the dependent attributes? What are the examples of the dependent attributes? Anybody? What are the examples of the dependent attributes?
Age depends on month, year.
Yes,
and day.
yes, very good, very good. So if at all we have considered the attributes age, month, birth date, birth year. So this age is the dependent attribute. It depends on all the three attributes, all the three remaining attributes. So if at all in a data set, there is a dependency exists among the attributes, it is too difficult to calculate the posterior probability of the tuple given class. So for the sake of simplifying the task, the assumption, Naïve Bayesian classifier assumes that assumes a class conditional independence. What the assumption here? I already told it in the last class. It assumes that there is a class conditional. What is this? What is this class conditional independence? This is the very, very important point covered in Naïve Bayesian classifier. This is only the speciality of Naïve Bayesian classifier. This thing we need to highlight when you are going to explain this or when you are going to present the topic in the exam. So what is the class conditional independence? It says that all attributes of the data set are independent to each other. There is no dependency among the attributes. It assumes like that. Actually, in reality, there exists some dependency, but it assumes that all the attributes in the data set are completely independent to each other. So with this assumption, the calculation of this posterior probability of the given tuple is simplified little bit. So it can be expanded like this. It can be obtained like this into P of X2 Ci into P of X3 Ci and so on. So the value of this posterior probability of the tuple given Ci can be obtained in this way. That means we need to calculate the posterior probability of each value of the attribute, and we need to multiply all the values, and we can get the posterior probability of the tuple given the class. So what is this x1, x2, x3? We know that what is a CI? CI is nothing but some specific class. We have performed for each class. One class first we need to take, right? That is CI. CI is some class. X is a given tuple. Then what is this? X1, X2, X3. So x1, x2, x3 are the values for the attributes a1, a2, a3. Why? Because here tuple in the sense it consisting of some attribute. It is a attribute vector. It is a attribute vector. Suppose it consisting of a1, a2, a3 and so on. Here is the tuple given. This is the given tuple. What is meant by tuple? Suppose from a student database, randomly I selected a tuple and the details of the tuple are name is equal to some, okay, name is equal to some what, Alekia. Next section is equal to A, and next branch is equal to IT, and marks is equal to some 90. Suppose this is the tuple I have drawn from the data set. So what is the content in the tuple? Alekia, IT, 90, A section. All these are the values of the attributes, right? All these are the values of the attributes only. So actually I can write the tuple like this. Name and section, some branch and marks. Suppose this is my tuple. So what is this? These are all the values of the attributes. This is the value of A1. This is the value of A2. This is the value of A3. What is A1? A1 is the student name. A2 is the student section. A3 is the student branch. A4 is the student marks. So all these are referred as X1, X2, X3, X4. So what are these things? These are the values of the tuple. Sorry, values present in the tuples. In turn, these are the values of the corresponding attributes of the tuple. Why? Because each tuple is represented as an attribute vector. Hope you can understand this. So here X is an attribute vector, right? And each particular value of the X is represented with X1, X2, X3, where these are the values of the attributes actually. So here the name Alekia is what? Value of attribute A1, where A1 is name of the student. And where the branch, where the section A, this is also value of the attribute A2, where A2 is the section. Here, next IT is the value of the attribute A3, where A3 is nothing but branch. So here also, X1, X2, X3 are what? X1, X3, X2 are the values of the attributes A1, A2, A3, etc. So our task is here somewhat simplified further. So first we need to calculate this product, right? First we need to calculate this product. And to calculate this, we need to calculate this 1 and 2. And out of these two, we already know the formula for these two. Second one, prior probability of the class, we already know the formula. And we have calculated many times in the previous examples also. And coming to the first formula, P of, that means posterior probability of the tuple given class. So for this, we have in the sense Naïve Basian assumes a class conditional independence. Naïve Basian assumes a class conditional independence. And according to this, each attribute is independent of the other attributes. There is no dependency exist among the attributes. So with this, we can expand that like this by using all the attribute values. So our task is to calculate this. For each attribute value, we need to calculate and we need to multiply it. We need to multiply all the resultant values. And after that, we are getting some value, right? We need to multiply that value with this. So that forms the whole value. And the same procedure we need to calculate for each and every class. How many classes we are having? The same procedure we need to calculate for each and every class. And again here we need to consider this. How to calculate this one? P of x1 by Ci. So how to calculate the posterior probability for a particular value of the attribute? So here again we are having two scenarios. if the attribute is categorical, if the attribute is numeric. So here again there are two cases. If the attribute value is categorical. For example, if you consider the same example, here this value is categorical, this is categorical, this is categorical, where this is numeric. So if at all the particular value is categorical, then there exists some procedure to go for further. And if at all the value is numerical, then there exists another procedure. So let me go through all these things again by sharing the PPT. Is the screen is visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, thank you. Let me expand this. So here I'm just briefing the things which we have discussed before going for directly the example of the Naïve Bayesian. So here it predicts the class membership probabilities, and it depends on Bayes theorem, and we are having two classifiers under this Naïve Bayesian classifier and Bayesian belief networks. Naïve Bayesian classifier, the main assumption is class conditional independence. That thing you need to highlight that when you are writing in exams also, you need to highlight that. And coming to the Bayes theorem, here is the formula for the Bayes theorem, where H is the hypothesis which says that X belongs to class C and X is the tuple. Here is an example, we have already seen that. And these are some notations. I told you there are M classes, right? M number of classes we are having in our example. These are all some notations. And this is the ultimate condition to satisfy, to set the tuple X belongs to the class Ci. And for this, we need to calculate this P of Ci by X for every class. For every class, we need to calculate. Because our goal is to prove that P of Ci by X is greater than that all the remaining classes. So in order to prove that, I need to calculate the posterior probability of the class given the tuple for each classes. How many classes we are having? Those many number of times we need to calculate the posterior probability for each and every class. And how to calculate that? From Bayes theorem, we are having a formula for that. So here is the Bayes theorem. So from this, just by replacing H with the, just by replacing H with the class, we are getting the formula. So after that, what we have done, since we need to calculate the same thing for each and every class, the denominator is constant for all the classes, right? So we have removed that. We have not removed in the sense we are not considering that in the calculation part. So we can only focus on it. So our goal is shifted to this one. Instead of proving this, we need to prove this. That means here, we need to prove this. So P of X by Ci, P of Ci should be greater than P of X by Cj, P of Cj, where the j is in between 1 and m and I not equal to the j. So we need to prove this. So for this again, we need to calculate these two. Again, we need to calculate these two. And there is a way of getting this prior probability of the class. Here is the formula. Now how to get this? How to get this posterior probability of the X given the class? So for this, its complexity is mainly depends on the number of attributes that particular tuple has. And for simplifying that calculation, for simplification, what is the assumption of the Naïve Bayesian classifier? It assumes a class conditional independence, which says that each attribute value is independent of the other attribute. So from this we can get it by simply having the product of all individual attribute values, posterior probability of all individual attribute values given the class Ci. So how many attributes we are having? Those many number of times we need to expand. Those many number of times we need to expand. We have expanded it up to n. Why? Because what is n? In the notations, what is n? This is the number of attributes. Number of attributes in a data set, which means that number of attributes in a particular tuple. So we need to expand it in n number of times. So next, what's our task? We need to calculate this. We need to calculate this. That means we need to calculate this. P of xk by Ci. That means for we need to calculate the posterior probability of each attribute value given the class Ci. Now here again there are two cases. If the attribute is categorical, if the attribute is numerical. So here if the attribute is categorical, it can be easily obtained by here. This is the number of tuples of class Ci in D having the value xk for ak divided by the Cid. That means the number of tuples of class Ci in D. So it is a ratio of number of tuples in the data set with the class particular Ci to the total number of tuples out of this total number of tuples in the class Ci with the particular value xk. Something irrespective of the notation, just observe the meaning of out of this. So it is the ratio of total number of tuples in the belonging to the particular class where the numerator is occupied by the number of tuples belonging to the particular class with the particular value of the attribute ak. It can be clear when we are moving for an example, no problem, not an issue here. So when the second case, if the attribute is continuous, if at all the attribute is continuous, so a continuous value is typically assumed to have a Gaussian distribution. So where the Gaussian distribution is like this. So if at all the attribute is continuous, we need to find out the Gaussian distribution, where mu is the mean and sigma is the standard deviation. So here is an example. If this is the given case, so for A's, the attribute A's and the value is 35, if the value is 35 and from the data set it is obtained that we have a mean of 38 for A's and we have a standard deviation of 12 for A's. So we can obtain this by simply substituting these values in these equations. So if we substitute those values in these equations, we can get the value of the P of xk by Ci. So let's take an example here. Okay, consider an example. Here is a data set. So here, what is C1? Is the screen is visible?
Yes, ma'am.
Okay. Just wait a second. So what is C1? This is the given data we are having. This is the given data set.
Computer equals
S
to
by computer is equal. That means C1 holds the S class, where C2 holds the no class, where X is the tuple which we want to classify, and this is the tuple given. I already told you X is nothing but the attribute vector. So what are the attributes we are having here? A is income. Just you can directly take it taken from the. This is directly taken from the data set. A is income. Sorry, A is income, student, credit rating. This is the attribute vector, and the values are also given here. Youth is the value for S, and medium is the value for income, and S is the value for student, and fair is the value for credit rating. So for this tuple, we need to calculate the class label. So this belongs to X belongs to S or no. This thing we need to calculate whether this is the class or this is the final label. That thing we need to calculate. So for that, first what to do? Here we need to maximize this. We need to maximize this. Maximization in the sense we need to calculate this for each and every class. So how many classes we are having? Only 2 classes we are having. So what is the expansion? P of x by first class is S, right? Second class is no. So P of x by Bayes computer is equal to S. P of Bayes computer is equal to S. This is two things here, right? So if at all it is no class, P of x by Bayes computer is equal to no into P of x by, sorry, P of Bayes computer is equal to no. So these two things we need to calculate first. Is it clear up to this point?
Yes, ma'am.
Okay. So first we need to calculate these two things. P of x by Bayes computer is equal to S. P of Bayes computer is equal to S. Okay, how to calculate that? There is a formula for that, right? How to calculate that? How to compute that? So out of all the tuples, how many tuples are there in the data set? Total. How many tuples are there?
14, ma'am.
Yes, 14. So out of 14, how many belonging to S class? Many times we are taking the set.
9, ma'am. 9.
Yes, yes. Now,
9 is
yes,
5 no.
yes, 5 by 14. So this is the value for P of C1 because we are just dividing the task into two parts. We need to calculate this one and we need to calculate this one for both the classes S and no. So it is little simple, right? Just we are going for this, computing the P of Ci value. So we need to calculate P of S class and we need to calculate P of no class also. So P of S class we are getting 9 by 14 value. What is that 9 by 14? What is that value? 9 by 14.
0.642.
0.642. We are getting this here. Next, P of no. P of no. 0.
0.357.
0.357.
Yes, ma'am.
Yes. Let me check that. My screen is stuck somewhere. Just wait for a while. Okay, anyway, it is struck somewhere. So we are getting this part, right? Till now, we are getting this part. So what is the next task? Which value we need to get? Next. Which value we need to get? P of
X by Ci value.
X by Ci in the sense S class we need to consider. Similarly, P of X by no class we need to find out. So we need to find these two, right? Because here these two cases we have already calculated. Again for S class is one case and for no class is another case. So we need to calculate P of X by S and P of P of X by no. So how to calculate P of X by S? What is the assumption in Naïve Basian classifier? What is the assumption here? Class conditional independence. That means each attribute value is independent. And for that we need to expand the formula P of X by S. How to calculate that? P of X1 by S into P of X2 by S, P of X3 by S, right?
Yes, ma'am.
Yes, yes. Yes. It is actually structured. So here P of X1, P of x2. How many attributes are there for that given tuple? For the given tuple, how many attributes are there? I think 4. I think 4.
Yes, ma'am.
So we need to calculate individual things and we need to have a product of all those. And again, what? This is for P of x by C1, right? And again, we need to calculate P of x by C2. So for that also, we are having P of x1 by no into P of x2 by no into P of x3 by no in the sense given the class no, P of x4 by no. So let's come with this. Suppose it is numbered 1, 2, 3, 4 and 5, 6, 7, 8. All these values we want, right? Let's calculate one by one. P of x1 by S class. That means out of 9 S classes, right? Right or no?
Yes, ma'am. Yes, ma'am.
Yes, yes. Out of 9 S classes, how many x1 in the sense, first we need to expand this. X1 is A's, I think we are having.
Yes, ma'am. Yes, ma'am.
X2 is income, huh?
Income,
Yes,
ma'am.
ma'am. Income.
Income. X3 student, right?
Student.
X4 credit rating.
Yes, yes. X4 credit rating. So here, out of 9 S classes, how many classes are having x1 value? That means having value A's in the sense, what is the A's value for the given tuple X? What is the A's value? Do you remember?
Youth, ma'am. Youth.
యూత్ ఒకసారి చూద్దాం లేకపోతే గుర్తుపెట్టుకోండి ఇక్కడ
ma'am. Youth,
స్లైడ్
ma'am.
పెట్టలేదు వెళ్ళిందమ్మయ్య ఇంకో వచ్చేసింది కదా ఇందాక ఈ 2 వాల్యూస్ కదా మీరు కనుక్కుంది these 2 values P of S prior probability of S is 0.643 and prior probability of no is 0.57357, right? And we are moving this because here we can have a table, no need to go for the whiteboard here. So in the above here we are having the values, right? What is the A's value? Youth.
Youth, ma'am.
And remember the remaining values also here. So what to do? Just we need to substitute that. Shall I go for the whiteboard or can I proceed here?
Whiteboard, ma'am.
Whiteboard is better, right? So remember the values. So how many youth values are there for the S tuple?
Two, ma'am.
2 youth values are there for S tuple.
Yes, ma'am. 2.
Okay. How many youth values are there for no tuple?
Three.
3. So remember that I'm going for the whiteboard. So here, how many youth values are? A's is youth, right? How many youth values are there? 4, ఇందాక ఏం చెప్పారు?
Yes,
Total
2,
5,
ma'am.
Yes.
This
Yes.
is 2, right?
Two.
Ma'am, no 3, ma'am.
No 3. So P of youth by no 3 by 9, right? This is also youth. This is next. P of what is the value for income?
Medium.
Medium.
So P of medium by S classes we need to calculate. Again P of medium by
No class.
no classes. So out of 9, here out of no classes and 5 kada?
5, ma'am.
5. So out of 5. So out of 9, how many S classes are out of 9 S classes? How many mediums are there? And out of 5 no classes, how many mediums are there? We need to see. I'm going back to the PPT. Look into this. How many for income? How many mediums are there?
4 years, 2.
4S and
4 years, ma'am.
2
Two
no's
no's.
and 2 no's. Okay. Again whiteboard. So here 4 and here 2. And next Next, what to calculate?
Student S.
Student. So P of student, yes.
by S.
So out of 9, how many students are there? And again here also P of student, no. Out of 5, how many no's are there? We need to see. So how many S cases are there?
6, ma'am.
6 S's. So remaining are the obviously no's, I think, right? So here 6 S cases are there and remaining చూసారా నోస్ ఎన్ని ఉన్నాయో? I'm going back to the PPT. How many no cases are there for student S? Here is one.
7S, ma'am.
What? How many? 4.
7S.
7 ఉందే 5 కదా. ఓకే, ఎస్లు 7 ఉన్నాయా? నోస్ ఎన్ని ఉన్నాయి? For student is equal to no, how many no's are there?
8, ma'am.
Sorry, for student is equal to yes, how many no's are there?
7, ma'am.
Remember that figure? Here, ఎన్ని ఇక్కడ? Out of 5?
7, ma'am.
7 Sలు.
Notes కూడా 7, ma'am.
Here for student value,
స్టూడెంట్ కి ఎస్ అయితే దానికి కూడా వై కావాలి కదా మేడం.
here out of 9 S classes, we are having 7 S classes for the student. Here out of 5 no classes, how many S classes for the student? Shall I go back to
6 S classes, 1 no class, ma'am.
6 S classes? 6 S classes and 1 no classes. Here in both the cases, student value should be S. The classes we need to consider. Let me go back to the PPT.
Ma'am, 6 classes and 1 no class, ma'am.
6.
S classes, ma'am. 1 no class.
So is it okay? Here, right?
Yes, ma'am.
Okay. And what is the next case? Next and last case?
Credit rating.
Credit
fair,
rating, what's the value of
Fair.
credit rating? Fair.
ma'am. Fair.
So for credit rating fair, given the class, yes. And similarly for credit rating fair, given the class, no. Here, since the values are also yes and no, a little bit confusion is there here. So out of 9 and out of 5. So out of 9 S classes, how many fair tuples are there? How many fair tuples are there with the class? Yes.
6 మేడం.
6, ma'am.
6. How many fair tuples are there with the class? No.
2, ma'am.
1 మ్యామ్.
2, ma'am.
2, ma'am.
Yes.
2,
2.
ma'am.
2. Yes. Yes. So ikkada this is 2 and this value is here
6.
6. I think we are with all the values in our hand, right? Both 8 values we are having, 4 sets and 2 values for each set, 4 to set. So what the next task? We need to multiply all the, what we need to multiply? All the S class values we need to multiply, right or not? All the S class values we need to multiply, and this gives the P of X by C1, and after that what to do? All the no class values we need to multiply. This value, and this value we need to multiply. This gives the P of X by C2. And what's the next step? We already have these values. P of C1 we have, P of C2 we have, right? So we need to multiply this value with this value and this value with this value, and we need to find out the one which is having the highest value, right? Did you get my point or not?
Yes, ma'am.
So let us see here. So since we are already having the value, we are already having the value of P of C1 and C2, we are already having that. And we have calculated this. So we have calculated this for both the classes as S and no. We have already these values. We have calculated this value just now. So what to do? We need to multiply this value with this value. So the value for S is 0.643 and value for no is 0.357. I think the time is over. Let me finish it. So here we have calculated the same thing, right? Which we have done in the whiteboard. So after that, we need to multiply that with the previous values. We have multiplied with the this value, right? These values we can obtain from the whiteboard, and these values we already have with us. We need to multiply this, and we are getting finally this value. So which is the greater value? 0.028. So what is the ultimate class of X? Yes, S is the ultimate class of X. S, ultimate class of X. So here the classification result obtained is what? What is the result?
Size computer equals to
Bayes
X.
computer is equal to X. And the same thing I'm going to repeat in the next class. Next class also. I think the time is over. Let me wind up the class. Thank you.